Okay, collision detection. I think the easiest to start with would be making the ball bounce from the top edge or the bottom edge. So, firstly, this is a new episode, so let's save Pong. Pressing tab auto completes the file name as far as it can tell. We've got a bunch of stuff saved as Pong 0 something. This will be Pong 05. There was already a file there, but that's fine. Okay. Control O, or that little button in the corner, go to Updates. To make the ball bounce off the top and the bottom of the screen, we need to see what its Y value is. But we're already stopping the paddle at the top of the screen, so this is exactly the same, isn't it? But instead of checking pad.y, we're checking ball.y. If ball.y is less than 1, it is during this frame, before the screen draws, it has gone over our imaginary gray line at the top of the screen. So let's put the end in before I forget. We need to make it go back. Now we can't just go ball.y is equal to 1, the same way we do the paddle. The problem is our ball still has a delta, so every frame it's still going to add to its position, and that's going to push it over the edge of the screen over and over and over, and it's going to correct it over and over and over. The same as if a player was holding down the up button the whole time. So this is what I'm talking about. So what we need to influence is its delta y. Now if it's at the top of the screen, as discussed earlier, y is negative going up, positive going down, because we're counting from the top left corner. So if it hits the top of the screen, it means at the moment our delta is probably negative. So we can just change it to positive, right? Save it. Just going to put a bookmark here so I can get back to it quickly, because what I want to do quick is go to the ball and give it a negative delta for y. So it's still going to move to the right 1 pixel per tick, but now it's also going to move to the top 1 pixel per tick. So diagonally up, and run it. Yeah, it works. Does that bounce inside the edge or below the edge? I think that was bouncing inside the edge, so it happens so quickly I don't think anyone would notice, and I don't like manually affecting the position of the ball because then it becomes unpredictable. So I think this is fine. The problem is this doesn't work for the bottom. So else if ball.y is, what did we have before? Y plus paddle height over 135. So if ball y plus ball size is greater than 135, then we change the ball's delta to -1. For the time being, we just pop to the top of the file again. I'm going to remove the delta x. So the ball's just going to go up and down on the net the whole time. And run it. Cool. That works. Except we've hard-coded the speed of the ball effectively. Because what if I make delta y 2? What if the ball was going faster? It'll go fast until it bounces and then slow down. Again, boop. Because we are physically overwriting the delta with a value. How do we fix this? Well, the easiest would be to just invert whatever delta we already have. So instead of hard coding the value of 1, we can say we want whatever delta y is now, but going the other way. And the easiest way, I don't know if this is a maths thing, but if you deduct the number from 0, it essentially just switches the sign. dot dy. So, what is going up with... Oh, it's my cursor that's on there. I thought it was a capital D or something. Okay. So ball.dy becomes the opposite of ball.dy. And we can do the same down here. 0 minus ball.dy. So this should have exactly the same behavior, except that if I set the delta y to 2, like it is now, it will always be 2. It'll just be going in the other direction. Boink, boink. Hey, it works. But we also have some code duplication. This line and this line, this line is exactly the same. So we're running the risk that our code expands and gets complicated, and we come to change something about ball trajectory over here, and we change this one, but we forget about this one, because they might be in entirely different places in the code. And they do exactly, typo, minus 0 is still 0. They do exactly the same thing. Those two lines are identical. So instead of having two separate else ifs, what if we go like such? You can put in more than one condition for an if. What if that or this is true? Then we don't need this section. Then if the ball is at the top of the screen or the ball is at the bottom of the screen, then we invert its trajectory, invert its delta y. It's much cleaner, much simpler, and if I decide to make the ball go slightly faster every time it bounces, then we can insert that here in one place. It's consistent across the whole program, and we don't have to worry about it. And as usual, to confirm, it still runs exactly the same way. Okay. Let's just give it a more realistic delta for testing purposes. So let's make it minus 1 and 1. So it'll move to the right. Actually, let's go to the left, because the D-pad is easier to debug with. So now the ball goes to the left, and it misses that paddle. Even if it doesn't miss the paddle, it does nothing, because the paddle doesn't have code yet. Here's the thing. Did I save? Yes, I did save. Now we need to handle collision detection for the paddles. The easiest way of handling that is what's called axis-aligned bounding box, or just bounding box for short. Here's one I prepared earlier. Collision demo. And run it. This looks like a lot, but let me explain. We are looking at, I can move this one, the arrow keys, or with the D-pad. We are looking at what is an object over here. It has a top left corner, that's its x and y position, and its bottom right corner, which is x plus width and y plus height. That gives us this. Now we need to know when this box overlaps that box somehow. So, like that. Now there's 4 things that we need to check. We need to check whether this edge of the box has gone past this edge. We're testing opposites. So, has the left side of my box gone past the right side of the target? In this case it's no, so we don't see left. When it does, we see right. Okay, this, by the way, is because it's an axis. We're looking at it down this entire line. So here it doesn't say left, here it does say left. The next one, has the right edge of my box passed the left edge of the target? No, it has not. Now it has. Right. Has the bottom of my box passed the top of this one? Yes, it has, because it's way below. And lastly, has the top of my box passed the bottom of the target box? See there, nothing, and then there it is. If all 4 of these things are true, it means somewhere we are overlapping, either here, or here, or here, or here. See, all 4 of them remain true as long as all 4 edges are past the opposite edge of the target. Okay, that is, if you imagine this being our game, here comes the ball, and then there it overlaps. So because this is a paddle and it's coming from this side, the ball then needs to bounce this way. So the ball logic is the same, except that it's bouncing on the x-axis. But the way we check if it's touching the box is by this bounding box code. So there's 4 conditions we have to write. And that was the short version of the 4 conditions. So we can write all of this in our... Ooh, don't look at that. That's complicated. Let's go back to Pong 5. We can put all of this in our updates function. But this is a single basic collision thing with the ball that we're going to check over and over. So as much as we were trying to keep our code in order down the file that it would run, this is the point where we're going to have to put stuff somewhere else. So down here, I'm going to make a thing that says, actually, what do I call this? Helpers? Let's call them helpers. Okay, we make a function for check. How do you spell collision? 2 L's. This is why autocomplete is handy. Check collision. And this, we're only ever going to check collisions with the ball. So we don't need to pass in an A object and a B object. We're just going to pass in the paddle that we're checking against. So maybe we should call this check ball collision. And then don't forget the end. Okay, there's 4 conditions that we have to write. If the left edge of the ball is to the left of the right edge of the pad. So pad.x plus, we know the pads are always 4 pixels wide, and we haven't added any latitude for that to change yet. May later, depending on what we want to do. But for now, we know that is our first condition. On the next line, and, because unlike the other one where we checked one or the other condition, this is only supposed to collide if all 4 of our conditions are true. The next thing we need to check is whether the right edge of our ball has passed the left edge of the pad. Ball.x plus ball size is the right edge of the ball, and we're checking whether it is greater than the left edge of the pad. That was our second condition. So now we have left and right. And basically the same but the other way around. The ball's top edge is above the paddle's bottom edge plus, what do we call it? Paddle height, right? So that is the top of the ball passing the bottom edge of the paddle. And then lastly, this is a lot, I know, ball.y plus ball size gives us the bottom edge of the ball is greater than the top of the pad. Then the nice thing about this is it stays reasonably consistent. We don't have to write this again. In most cases, if you want to do bounding box, you can just search for it online and find the code or a helper function in whatever language you're using. A lot of languages have libraries that allow for this, but the nice thing about TIC-80 / this whole community is the fact that you have to write stuff yourself, which means you understand it by the time you're done with it. And I really enjoy that. So if the left edge of the ball is past the right edge of the paddle, if the right edge of the ball is past the left edge of the paddle, if the top edge of the ball is past the bottom edge of the paddle, and if the bottom edge of the ball is past the top edge of the paddle, then we have at least one point between the ball and the paddle where they overlap. So the ball needs to bounce the other way. But we're not, I mean, I can go ball dot delta x here equals to 0 minus ball dot delta x. Problem is, this is a check function. We shouldn't be doing logic in a check function. So we're going to do the change in trajectory in our update function. If all of these things are true, we return true. Yes, there is a collision. If it goes through that function and wait, no, there, no. If it goes through that if statement and one of those was false, then we have to return false. Now this is redundant because if all four of these were true, that one, that one, that one, that one, then this will return false. We don't need to put else here because there's nothing else happening in this function besides that check. So the end still needs to be there. But we can just put that there. In other words, if all four things are true, it returns true. If it reaches this line of code, it returns false. So at least we know this function will always return either true or false. Less effort, less things to worry about, less calculations. Now where do we use this? In updates. So after checking whether the ball has bounced the top and the bottom of the screen, ball edge bounce. Now, bounces? Sure, why not? Now we need to check whether the ball is overlapping with one of the paddles. So we can use the same logic as we did for checking both paddles. Thus, we can use again, because the two paddles are functionally identical. For each of the two paddles do if. Now here for the first time we're going to call it's not calling the first time we're calling a function to check a condition, because we did that with the button presses, with the buttons for the controllers. This time is the first time we're calling a conditional from our own function. So if, what would we call it? Check ball, what do we call it? Check ball collision. Check ball collision for whichever paddle we're looking on. Now I can be verbose and say equals to true, but it doesn't have to, because as long as this function returns true or false, the condition will work. Then end. So pick a random paddle, left paddle. If the ball is overlapping the left paddle, we need the ball to bounce towards the right. If it's overlapping the right paddle, we need it to bounce to the left. But the same way that we don't care which edge of the screen we're bouncing off to change its Y movement, we don't really care which paddle it is to change its X movement, because it's impossible for the ball to overlap both paddles at the same time. So ball.dx becomes the negative of ball.dx. Right? Okay, let's run it. When last did something work first try? Blink. Look at that! And then if it misses the paddle, it didn't collide with the paddle, so it just left the screen. It even works. Okay. I hope I explained that succinctly. We've implemented our first collision detection and prevention. I don't know where I was going with that. Wouldn't it be nice if there was a bit more feedback? Maybe it's time for us to add some sound. So, buttons up here, That one is the sound effects editor. Now this looks very intimidating, because it kinda is, but there's 3 different synthesizer waves that make different sounds. This is the volume of the note that's playing. If you go to wave, you can actually change what noises the things make, but we're not going to get into that. And then down here's a piano, and you click on a note, and it plays a note. I'll tweak the sound if that's too loud, but for me that is damn loud. Boop. Okay, terrible. This one sounds like this. This one sounds like this. Now, none of them really sound like a ball bouncing, so we're going to have to do some changes. Okay, let's make the first one the ball bouncing off the top and the bottom of the screen. So we want a short sound. So after, I don't know, after there, we just kill the volume on the sample, which means if I play it now, it goes, hey, that's not entirely terrible. It kind of sounds like the old Pong that was on whatever that machine was. That's a bit long. Let's make it shorter. But lower pitched. Okay. Over here is the index of this sound. This sound is called index 0. So in our code, we find where the ball bounces off the edges over here. So after changing its trajectory, we're just going to play a sound effect. SFX goes green, which means it's the name of a function, and we tell it we want sound 0. Save, as always. Run. Hey, it made a sound. Why is it still making a sound? Because the ball still exists outside the screen over there, and it's bouncing up and down. We'll get to that later. Next episode probably we'll write an init function and a reset function so that we can actually play a game with this. We're getting somewhere. Okay, so that's the ball bouncing off the top and the bottom. Now, let's go to index 1. Now we need a sound that sounds like the ball hitting a paddle. So what if we take exactly the same sound, copy, go to this one, paste, keyboard shortcuts, and then take the same sound. See, there's a little dot there on the C. If I move that up, say a minor third, to that semitone key there. So then I'm using spacebar to play the sound, by the way. And left and right arrows to change which sample is selected. That's good. Okay, SFX1 when the ball bounces off a paddle. So, grab this quick. Where does the ball bounce off a paddle? Right here. For sound 1. Hey! This is starting to sound like something. That was impossibly simple to implement. Yay, okay. This can carry on forever. I'm playing against myself right now. So we might want to consider adding something that makes the game more difficult as we go to force someone to lose faster. Maybe make the ball go faster, maybe make the paddles go smaller, maybe influence the speed of the paddles, I don't know. Make the ball pitch at an angle when it hits a paddle, maybe based on movement or where on the paddle it lands. Anyway, it works. Okay, I think we call it there for now. This has been, what, probably about 25 minutes. And then in the next one, we'll look into what if someone scores, how do we reset the thing, and how do we display score. Did I save?